All right, there's some hard problems on this sheet. I'm not going to do all of them here. I will post the solution document. I'm going to talk about some. So this first one, number one, that's super hard, but you have three triangles here, and the fact that that's perpendicular and that's perpendicular, all three of these triangles actually end up being similar. Let's here. Let me show you. Let me put the big triangle in the middle. So let's say triangle SNE. Well, that triangle SNE is going to be similar to this one on the left, right? Because they have this reflexive angle S, and they both have a right angle. So if I said SNE, the triangle on the left would have to be what? That would be SWN, okay? And then the triangle on the right, they have this reflexive angle E, so the E still has to be last. The right angle was in the middle, so this would be NWE. So all three of these triangles are similar to each other, okay? So when you're doing something like this, you have to, pay attention to the letter pattern. NW, let's see, we're doing NW, we're doing WE. So it looks like we're dealing with these outer two triangles, is what I'm seeing. So NW, 6, that has to match up to WE, 2. Let's see, we're given NE. So that's that. So I'm going to have to put that on the bottom, and that matches up to SN right there, right? Okay, and then you cross and solve, and you get SN equals 18.6. You got to be careful with that matchup. Okay, now this next one, I'm going to erase what I had here now, these markings, and I'll do this next one. NS is 12, so that's in there. It's also there. SW is 10, so that's only in this one, so I'm definitely using this triangle. Okay, SW is 10. It says find SE. Okay, let's take a look. So I actually have this NS in two triangles, so I'm going to be using these. So I'm going to do this triangle on the left, SN, and you see that matches up to SE. Well, SN was given to me as 12. Okay, SE is SE. What else do we know about this triangle? Well, we know SW is 10. And that has to match up to SN. Oh, wait, I know SN is 12. So you got 144 equals 10 times SE. SE equals 14.4. So these next, the one in the middle I'm not going to do. We've done problems like that. You can try it yourself and check your answer on the solution doc. This one's kind of cool here. Watch this. So that's AB is less than 3 less than twice BC. So we don't know anything about BC. Call it X. Whoops. 3 less than. That would be take a 3 away from 2x. 3 less than twice BC. So we got this angle bisector going on. So x over 8 equals 2x minus 3 over 6. Now, when I go ahead and do my fancy cross multiplication, I end up getting negative 10x equals negative 24. So the negatives cancel, and I get 2.4. Now, you're asked to find the perimeter, and you could certainly find some kind of perimeter by plugging in this 2.4. But you know what? Perimeter comes out to 18.2, but this is not a triangle. Okay, it doesn't exist. Because if you take 2.4 and put that in here, and you have 2 times 2.4, what's that, 4.8? 4.8 minus 3, it's going to be 1.8. You see, you can't make a triangle with lengths of 14, 2.4, and 1.8. That's just not possible because the two short sides have to add up to more than the longest side. Talked about that before. Okay, now back here, this these can be hard. So I'm not going to do the top one. You can check your answer with that one. That one's not too bad. But these here are, we got parallel lines all over the place. CG and my computer's wigging out again, of course. Okay, here we go. So we have let's do a little bit of labeling here. We have that's 4. We have that's 6. Find the length of BD. BD will, whoops, I got disappearing ink. That's not good. Let's see if I can get this thing to work a little bit better. Sometimes I can, sometimes I can't. Okay, I'm going to try again here. So 4, 6. Let's call this whole, gosh, that's not good. I might have trouble here if I can't get this thing to work. And try again. Let's see if it sticks. Let's call that whole thing X, okay? Now you got, because of this these parallel lines, you got similar triangles. Now watch this. I gotta do a little highlighting here. Okay, so let's see if I can get a highlighter going. We'll try to go with yellow. And what you realize is that, like, this triangle here is going to be similar to this triangle here. Okay. So with the yellow triangles, the yellow similar triangles, you can say that oh, sorry, I messed this up. I don't have a, hold on a second here. Let's do the yellow triangles here, because this will be consistent with what I'm going to post. You see, that triangle is going to be similar to this one. So what you're going to have is 4 is to 6. This is a little side splitter, right? 4 is to 6 as AG plus GF, this is a little side splitter, is to that bottom part FE. Now let's just hold on to that thought for a moment. Okay, so now what we're going to do is we're going to highlight some other triangles. So you got this one up here that looks green now, but I'm using blue. So these are going to be congruent. Sorry, similar. And that's what I was getting at earlier. So the blue similar triangles, again, we're going to do side splitter again. 10 is to BD. okay, as AG plus GF is to FE. Ah, that's kind of cool, right? So check this out. You see, we got the same thing twice. So that means 4 over 6 is equal to 10 over BD. And BD would be 15. I don't know why I put this X thing in here. I didn't use that. That one's hard, for sure. For sure. Okay. Now down here in the bottom, we got one more to look at. Okay, let's get a little bit of labeling going on here. We got a parallelogram. We got a FG is 3. We got DF is 6. And we're asked to find the length of GE. We'll call that X. Okay. Now, let's see here. We do have a parallelogram. That's going to be important. Okay. And let's see. Because of that, we have some parallel lines, which gives us some alternate interior angles, right? So I see some triangles here that are going to be similar. Hold on a second here. Okay, so my bad on this, folks. Sorry, remember, we have some similar triangles. Got distracted there. Got other people here in the office. So these yellow triangles, I hope you agree, are going to be similar, right? Because we have those angles there, and you got vertical angles, right? So they're going to be similar by angle. And this 3 is going to correspond to the 6. So the yellow triangles are similar, ratio of 1 to 2. So I don't know what this side is, but I'm going to call this y, and this would have to then be 2y. because it has to be 1 to 2. Okay? Good with that? Now we also have more similar triangles. We have this one here, similar to this big one here, because of the angle. And 6 corresponds to x plus 3, so you have green triangles similar as well. X plus 3 is to 6, as 2y is to y. These y's cancel. Okay, so you get x plus 3 equals 12. So x is clearly 9, and that's GE. All set.